Hello Gators, this is 10-2, Day 2. Lines tangent to a circle. I can use properties of tangent lines to solve problems. Let's take a look at this picture and notice that we have two tangent lines, and of course a tangent means that you're going to have a right angle, so we do have the two right angles. Now these two tangents are from the same point, and we're going to create a quadrilateral, and within this quadrilateral we can draw another line and create a triangle. So there's two triangles right here. And we know that two of the sides are going to be congruent because they're both radii. We know we have a pair of angles that are congruent because they're both right angles. And we do know that we have a reflexive side right here. These two sides are congruent for these two triangles. So these two triangles are congruent by HL. And once they're congruent, then these parts right here are going to be congruent by CPCTC. So that's what we call the segment tangents to a circle theorem. So these are tangents, and whenever you have tangents from the same point right here, then the conclusion is that these tangent segments will be congruent. Let's go ahead and use that theorem to help us solve this problem. These are two tangents, so these two tangent segments must be congruent. So we can say x squared plus 2 is equal to 11. X squared is equal to 9. X will be equal to plus or minus root 9, and plus or minus root 9 will be plus or minus 3. Notice that we have two answers. The negative answer can work, or the positive answer can work, because when you put a negative in here, the answer will be positive. So make sure you understand the two answers work. Let's go ahead and do these. These are tangents, and so therefore this tangent segment will be congruent to this tangent segment. So x will be equal to 4. This tangent segment will be congruent to this tangent segment. This will be x is equal to 2. And this is a little harder. This tangent segment will be congruent to this one. We got to do a little bit more algebra. And then this is x is equal to 5. Let's go ahead and use this tangent segment theorem to help us find the perimeter given the tangents to the circle. We want to find the perimeter of the triangle right here. Now, we know these are tangent segments, so these two will be congruent to each other. These are tangent segments, so these will be congruent to each other. And these are tangent segments, so these will be congruent to each other. So to figure out the perimeter of the triangle, I will have to take two of these 5.4s plus two of the 14s plus two of the 13.6. And when I put that in my calculator, that's going to be I get 66. So the perimeter of the triangle is 66. Let's go ahead and try this again. I know that this is going to be congruent to this, so this is going to be a 12 and a 12. This is going to be congruent to this tangent segment, so this is a 14 and a 14. Now, if this is 12, then the leftover, let me change my color, the leftover will be 12.7. And that's because these two have to add up to this number here. And then this tangent segment will be equal to this tangent segment. So the perimeter will be 2 12 tangent segments plus 2 times 14 plus 2 times 12.7. And let me go ahead and figure that out. And that answer is 77.4. So the perimeter of the triangle is 77.4. Let's try this one again. I'm going to work right here starting at this one. This is 12, and so this one will be 12, which means that this leftover part, I'm going to change my color, is going to be 8.9. And then this will be 8.9. And once these are 8.9, I'm going to change my color again. And then 18.7 take away 8.9 will be 9.8. So this segment will be 9.8, and then this segment will be 9.8. And then I'm going to change color again, and I'm going to find the leftover from 15.1, which is, that's going to be 5.3. And then this tangent segment will be 5.3. And so now I can figure out the perimeter, because I really did know this side, and this side. What I didn't know was this side. This side was the one that I had to figure out. And what I did is I walked around the whole quadrilateral to figure out the little pieces. So this is the perimeter will be equal to 15.1, that's one side, plus 18.7, plus 20.9, and now I have figured out that last little piece, which is 17.3. And let me go ahead and put that in my calculator. And I have 72. So the perimeter of this quad is 72. All right, let's take a look at this same picture of this tangent segments. And remember, these are tangent segments, so we know that these for sure are right angles. And now they want us to figure out the central angle right here. Now remember, all four of these angles have to add up to 360, because that's what quads add up to. And we know two of those angles are 90. And the other two, one is 61, and the one is what we're looking for. So 61 plus x, I'm going to subtract these two 90, and that's 180. So 180 take away 61 is, this angle is 119 degrees. Now, to do this problem, I'm going to take a shortcut, because I know that these two are 90 degrees. So I know that these two have to add up to 180 degrees, because all four of them have to add up to 360, and I know that two of them are already 90. So these two have to, what we call, be supplementary. So I'm going to take 180, subtract 44, and this is 136. So these two add up to 180, these two add up to 180, so they add up to 360, which is what quad should add up to. All right, so let's take a look at this. Again, we have tangent segments. So this is a right angle and this is a right angle. Remember that these two have to be adding up to 180, and these are tangent segments, so they're congruent. So this segment will be, distance will be 17. And to figure out the distance, angle FGH, I'm going to have to take these two angles, and they have to add up to 180. So this will be 5x is equal to 180, and x is equal to, 5 goes into there 36 times. And once I put 36 back into here, the answer will be 72 degrees. So that's how big FGH is. Okay, we've covered some theorems in section 8.2. We covered theorem about a tangent to a circle and the fact that tangents are perpendicular. We've also, in this lesson, covered a theorem about two tangent segments from the same point. They will be congruent. And we also covered a theorem about the relationship of the central angle to this angle over here, that these two angles are going to be supplementary to each other because all four of these angles have to add up to 360.